Oh, hey, Miss T. Guess what? I just won 9 prizes at the state fair.
Yeah? Well, I won 10 polynomial operations.
Whoa! I guess we know who got the better prize.
Speaking of polynomial operations, we can do them!
Oh.
What we have to remember, though, is a standard order of operations. So either BEDMAS or PEMDAS.
I saw some PEMDAS at the state zoo. So anyways, we've got some examples.
Yeah, so taking a look at this first example here, if we're thinking of BEDMAS, the first thing is brackets. But looking at each of these brackets here, there's nothing that we can do to simplify that. We can't collect any like terms, we can't do anything. There's no exponents to deal with, so next would be our division or multiplication. And we have one multiplication statement here and a second over yonder. As we can tell from previous expand and simplify questions, the multiplication here, we just have to distribute both terms. So we end up with x squared plus 2x minus x minus 2. And I'm going to keep that still in my brackets here, just in case I have any other operations that I still have to perform.
Smart.
And then I have plus this second product there, that multiplication statement, where I will get x squared plus x plus 4x plus 4. Now, the reason that I kept those two products in brackets is sometimes there is another term there. So there might be a GCF that I have to distribute, or a coefficient that I have to distribute, or that might also be a negative sign that I would still have to distribute. So that's why it's incredibly important. At this point, I notice that it's just a plus sign. And so with the plus sign, it doesn't actually change anything. It's like distributing a positive 1 to each of my terms. Well, that's not going to change a single thing in this particular case. So just for funsies, I'm going to rewrite this whole thing, but this time, you know what? Let me collect these like terms while I'm at it within these brackets. Whoop. X plus 4x is 5x plus 4. I'm going to continue on and collect even more of my like terms. I notice that I have x squared and x squared, so that gives me 2x squared. I also notice that I have x and 5x, which gives me 6x. And last but not least, with my constants, I have negative 2 and positive 4, which gives me positive 2. And I've now expanded and simplified my entire expression here.
Cool. We encourage you, of course, as always, to pause these videos, give things a try, see what happens. So try this one. We are going to forge ahead, though. So if you've already tried it, which I'm sure you have, then see if your answer matches this. And again, we've got a couple of things. There's nothing to do within any of these sets of brackets. So at this point, we can play with our product, right? This multiplication here, this multiplication here. So our first product involves 2x minus 3 times x plus 1. So expanding and simplifying that, we have our 2x squared. We have 2x, we lose 3x, we lose 3. And we are subtracting the product of x and x plus 2. So we're subtracting x squared plus 2x. And as Ms. Tibbs was saying before, it's very important that we kept those brackets initially, just in case there are other operations that had to happen. In this case, we have to note that we are subtracting not just the x squared, but this whole entire polynomial. So in doing so, the only way we can open up the brackets is to apply that subtraction to that entire next term. So we're subtracting x squared, we're subtracting 2x. And then we can collect like terms to finalize this thing. So I can collect 2x squared with this negative x squared. which is just 1x squared, we have 2x minus 3x minus 2x, which leaves us with just negative 3x, and then this poor little negative, that's a pen. This poor little negative 3 is just running around on its own. But we'll love it all just the same. That one is done.
All right, next. Still following the order of operations, but we can see here in this example we have this exponent. And exponents come before our division and multiplication. So what does it mean to square something? Right? If we have 2 squared, that means 2 times 2. If we have negative 5 squared, that's negative 5 times negative 5, because everything in the brackets is being squared. So similarly, when I have my 2x minus 7 squared, that's the same as 2x minus 7 times 2x minus 7. And I'm just going to rewrite this latter half here without making any changes. So, this product, again, we're going to go ahead and FOIL. So we end up with 4x squared minus 14x minus 14x plus 49. And we're subtracting the product of x minus 18 times x minus 5. So again, we can FOIL, we could do our double distribution and get x squared plus 5x minus 18x minus 90. All right. Next, we could see if there's anything that we could collect, like terms in our brackets, right? Because our brackets will come first. But we also might notice here that we have this multiplication of a negative 1 to this last remaining bracket here, right? So we'll also have to distribute that. So whoop, 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 whoop. We'll have to do that as well. So maybe we'll just break it down real quick into 2 speed steps. So I will start by collecting my like terms. So I get 4x squared minus 28x plus 49. Whew! And I'll still collect these terms here, but I'll leave the minus for the next step. So I get x squared minus 13x minus 90. Now is when I will go ahead and distribute that negative. If you wanted to do this in one step, you're more than welcome to. Just for the sake of clarity, though, I wanted to make sure that we did it step by step. So when I distribute that, I get negative x squared, positive 13x, and positive 90. Big mistake is that people only will distribute that negative to the first term rather than every single term in the bracket. But again, remembering that this is essentially a negative 1 that we're distributing to each of those terms. Alrighty, now we're cooking. So taking a look here, we're now just going to collect our like terms. So we have this guy is an x squared and this guy is an x squared. 4 minus 1 will give us 3x squared. Next here, we have our negative, whoop, that's a pen. You did that same thing, eh?
Yeah.
Negative 28x and positive 13x. And that gives us our negative 15x. And last but not least, everyone's favorite, our constants. We have positive 49 and positive 90. Those add to give me positive 139. Boop, 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 boop.
So just as we squared something in this example, our next one, which is the last example of the day, has us cubing something. And we ask, what does it mean to cube something? I triple dare you to, honestly, just try it out, see what happens. If you're feeling really optimistic, I suppose you could try it in pen, but I always recommend pencil or something erasable, like, for example, that. But what it means to cube something is to multiply it by itself with something, it's a factor 3 times. Like, negative 3 cubed is negative 3 times negative 3 times negative 3. In the same sense, when we cube x plus 2y, that means we have x plus 2y being multiplied by x plus 2y, and since it's to the power of 3, there's a third x plus 2y. And when we choose to go further with that, well, there's a couple of multiplications to take care of, but we can do that in any order. I'm going to tackle these two first and leave this other one just on its own. So this one I'm going to leave intact. The rest I'm going to multiply. This product will tackle. So, foiling that out, we have x times x, which is x squared. We have x times 2y. We have 2y times x. And 2y times 2y. That is that greenish product, that seafoam green product. And again, that last factor I just left on its own. And that's still a pen. So that just stayed same. I can take a moment to collect like terms in those brackets in that first set. That'll make my life just a bit easier. So x squared plus 4xy plus 4y squared. And we're not done because we haven't fully expanded and simplified. So now we go back to our polynomial operation of multiplying higher order polys, meaning that each of these terms will multiply each of these terms. So everything in the trinomial is multiplying everything in the binomial. So taking x squared and multiplying it by those two, we'll get x cubed plus 2x squared y. We'll take 4xy, multiply it by everything, which gets us 4x squared y plus 8xy squared. 4y squared times everything will give us 4xy squared plus 8y cubed. And there's a bunch of terms that can be comboed there. So x cubed is on its own. There's no other x cubed term there. We do also have, okay, I've had enough of that, 2x squared y and 4x squared y, which we cannot combine with 8xy squared. Yeah, they both have x and y, but make sure that each variable has the same exponents. So just those two together, 2x squared y and 4x squared y, is a sum total of 6x squared y. And we've also got 8xy squared and 4xy squared. And finally, this 8y cubed is just on its own. This one is done. There are no more like terms that can be collected. There's nothing that has the same combination of variables and exponents. So that one is done. There is some textbook practice work for you, which we would very strongly recommend doing. You can find it there. Give these a try. If you run into any difficulty at all, or if you have any questions on this lesson,